Así que le voy a dar la palabra al profesor Luis Merino, que va a darle algunas instrucciones a sus estudiantes para luego ya empezar a presentar al profesor Jay.
Sí, bueno, buenos días. Bueno, gracias. Buenas tardes a todos. Acá también están los alumnos del curso Construcción Sustentable, donde tocamos varias de las temáticas que va a ver el profesor, ¿cierto? Por lo tanto, era relevante su asistencia a esta oportunidad. Tomen nota en la medida de lo posible, ¿cierto?, de lo que se vaya presentando, porque esto también va a ser incorporado, ¿cierto?, en el ítem de evaluación de este tópico cuando lo veamos en la asignatura, ¿ok? Así que bienvenidos y daremos prontamente inicio, supongo.
Ya, gracias Luis. Si María José nos dice si quiere hacer una prueba de traducción acá en la pantalla. Se está conectando. ¿Ya? ¿Cómo está la familiaridad con el inglés? ¿Bien? ¿Sí? ¿Les hace...? Si él habla lento, le pedimos que hablen un inglés académico lento. ¿Están ok? ¿Sí? ¿O no? ¿Sí? ¿Sí? Ya. De todas maneras vamos a tener esta ayuda en la pantalla. Está sincronizando, entiendo, con el sonido, que quizás no está tomando desde este micrófono, está tomando desde otra input. Hola, hola. Hello, hello. ¿No? ¿Quieres que empiece a presentar en español o no todavía? ¿Sí? Okay, so Jay, we introduce first in Spanish. Okay, I'm gonna introduce yourself. Oh, hello, hello. Yeah, it has a delay. At least the algorithm is understanding my strong accent. Mi fuerte acento. Bien, ya. Estamos okay. So Jay, I'm going to introduce yourself to the our guest today in Spanish, yeah, and then I am going to give you the time for your lecture, okay, yeah. Bueno, buenas tardes todas, todos los presentes. Gracias por darse el tiempo de estar aquí hoy día con nuestro invitado, el profesor Dr. Jay Yong, quien es profesor asociado en la Universidad de California de Davis, ¿cierto? La Universidad de California o la red de UC, ustedes quizás son familiares con UCLA, ¿cierto? UCLA, UC Davis, UC Irvine, es una red de universidades en California, ¿cierto? De las universidades públicas de California, y Jay trabaja en una de ellas, que es la que está ubicada en Davis, ¿ya? Cerca de Sacramento, en California. Profesor Jay es también director del Centro de Tecnología de Iluminación, que está ligada a la Universidad de UC Davis. Jay es por formación arquitecto desde Corea del Sur y con un máster en Building Science o de Ciencias de la Edificación de la Universidad del Sur de California y su doctorado en arquitectura también de la Universidad de California, USC, University of Southern California. ¿Ya? Así es que Jay es mi amigo también, ¿cierto? Hicimos el doctorado juntos en arquitectura en la USC y hoy día nos visitas también como invitado del proyecto Fondesit de iniciación que ustedes ven acá, que es el proyecto de investigación gracias al cual pudimos invitarlo. ¿Ya? Así es que agradecer a los colegas de la Facultad de Ingeniería, acá el profesor Luis García, profesor Luis Merino, también por invitar a sus estudiantes, por facilitarnos este espacio, a todos nuestros estudiantes de arquitectura, ¿ya? Gracias por venir acá y todos quienes también nos acompañan no necesariamente nuestras clases, profesores, ¿cierto? Colegas de la Facultad de Ciencias Físicas y Matemáticas por ahí, ¿cierto? Veo. José, gracias. Rodrigo Ruiz por acompañarnos hoy día, ¿ya? Así que espero que sea una charla muy útil. Los temas que nos va a hablar Jay son temas de punta en términos de iluminación y los impactos en la salud y el bienestar de las personas. Él va a cubrir un amplio, digamos, espectro de topics o tópicos. Así es que creo que sin más introducción le voy a pasar la palabra a Jay. So, Jay, thank you for being here. So, is your mic working? Well, aló, aló. ¿Sí? Acércate un poquito más.
Hello?
No? Can we replace it?
Can you hear me now?
Okay.
Okay. Can you hear me? Yeah. All right. Very nice to meet you here. I'm very honored to present my research work in front of you today. Professor Andrea Martinez, she invited me to join her research projects at the classroom in Los Angeles, not California, Los Angeles, Los Angeles in Concepcion. So I came here to work with her, but at the same time, I'm really glad to have this opportunity to share my research area and then, what my center has been doing for the California state to address the energy issues and then climate change issues. So as you see from the title, I'm going to talk about many different topics ranging from the energy efficiency to human health and well-being. I believe you will have some interest in different projects I'm going to present today. So I hope you will enjoy my presentation today. Okay. All right. So California Lighting Technology Center, that's where I'm working as a director. And I'm also a professor. So I'm teaching classes, but I'm also running this center with 20 plus full-time engineers. So I'm a design professor. So I work with design students, but at the same time, engineering professionals, their work relationship. So I have a very interesting, work experience working with the designers at the same time, the engineers. I believe that we have many students here from architecture and then also engineering department. So I want to see like what type of questions you might have after listening to my lecture. So the center, the CLTC, was established 22 years ago with funding from Department of Energy in United States. The goal was very clear. At that time, there was introduction of LED technology in building, and then no one really understood how to correctly utilize this technology. So United States government, they actually wanted to establish this center to advance the LED technology and also at the same time to correctly evaluate LED's performance for building use. So that was the reason for the center, like how the center was established. We are now working on many different topics. As you can see here, building controls and then indoor, outdoor lighting, smart home technologies. That's what we are also studying now. If you are familiar with electric vehicle, EV charging station is now a very important part of residential building and commercial building in the United States. So we are also testing EV charging technology, how we use EV charger, like EV charging, systems and batteries for the operation of the building. That is a very important topic these days in California. And then human health, like you will be able to see a good example of human health focused research, how light influenced human health and then human mind. That is also one of the big research area we are doing. CLTC is working with many different partners, government agencies, and then utilities who provide electricity and natural gases in California, and also industry partners. You might see some names like familiar to you, like a Toyota, Honda, Panasonic, many Japanese companies. They actually fund our research center to investigate their research area. But we also get funding from the architecture firms and the lighting manufacturers and many different industry partners. LED manufacturing companies also our big partners. So the relationship here is very interesting. Like we mostly rely on government funding from the California government. And then when we get those multi-million-dollar projects, we partner with industry. So industry provide their latest technology. We use the technology and then we advance the technology with the government funding. So it's a win-win, strategy for both, industry, government, and then also community we are working with. So research and development, that is the most of our project type, applied research. We don't really do fundamental research, but we do R&D and then patent and then commercialization of the technology. And then we do demonstration outreach. Demonstration is a very important part of academic research because once you get funding from the government, if you can utilize that money to improve the community environment, then that can be the direct benefit to the taxpayers. So we always try to use our funding to do the demonstration, especially in underserved community, and then improve their like a living quality. So you see, there are 10 different UC campuses in California. University of California, Davis is one of the UC campuses. All UC campuses across California, those are our test bed because we have a full access to those campuses. We also have many access to different cities across California. The reason we are getting the funding and then the funding sources are coming from the California government agency. So those city municipalities, they also become very cooperative to help us to install like different technologies and showcase those technologies. Code and standard is also a very important task for us. There is a building code and standard in California, which is called the Title 24. I actually learned that in Chile, there is no energy code and standard yet for building. So development of this type of energy regulations in building is very critical because once you have these regulations and then you can actually have a basis to even further improve your building energy efficiency and technology. So we work very closely with the California government agency. There's an agency called the California Energy Commission. They are the one who develop the energy code every 3 years. And then we support those activities by running our projects. So the funding from the agency is support us to run our research projects. The research outcomes goes back to the government agency. So they can use those evidences for the further building code and standard development. Is the translation working? Well, okay. Education training, that is also important. We do electrician education program because now you can actually see that building technology becomes more and more complicated. Now we have many dynamic systems for the lighting, HVAC, fenestration, windows, and then many other systems. And then we actually found that the technology is available already, but the people who install those technology in building, they were not really well trained to perform the task. So we actually developed a program to train all the electricians in United States so they can properly install very complex building systems in. Okay, so let's go to the topic. So in the past, 20 years, building technology, building energy efficiency has, that type of study has been prolific. There was a really big boom in this type of research because of the concern of the climate change and then the need for the decarbonization. There are many different reasons. So the government policy, new technology like LED, and then dynamic systems to control those different technology, there have been very big improvements in those areas. Practitioners like lighting designers and then architects and then energy and analysts, many different professionals, they also have been very well educated and practiced. So combining all these different factors, like we were able to achieve a big improvements in building energy consumption. Building energy consumption is really important because if you just end up like building, your buildings like in any way, like, and then consume energy as much as you want. Now we can struggle with this power outage issues in different reasons. So keeping the threshold in every single building, and then maintaining the good, resilient energy consumption in a region or country, that is the first way, way to get more sustainable and then healthy community. So if you look at lighting technology, LED, this actually diagram shows very interesting trend. This is the data from the United States. You can see like a 6-year period from 2012 to 2018. There has been big, increase in the LED adoption in building, while there's a big decrease in incandescent and fluorescent lamp in building. So 9% to 44% in all buildings in the United States. That has been really big achievement. But unfortunately, after this, increase, there has been somehow like a very slow improvement. Now, like last year, Department of Energy actually released the data saying that in United States, less than 50% of the building actually has LED. So even with all this new technology and adoption and program incentive programs, this LED adoption has been slowed down. I think that Chile probably has pretty much like the same adoption rate as the rest of the world and the United States, because in the worldwide, the LED adoption has been actually lower than 50%. But there is a still improvement here. If you compare the energy consumption between LED and then incandescent or fluorescent, you can actually see a big energy saving with the LED. That is the main reason actually we always like promote LED technology. This LED technology actually has changed, how the building is consuming energy as a whole. You can see that commercial buildings now, they consume lighting energy. That is, less than 10% of the total energy consumption in building. If you look back 20 years ago, lighting energy consumption in commercial building was up to 40%. 10 years ago, it actually goes to 20%. And then now it is less than 10%. Why? Because the lighting system became much more efficient. Okay? While the other system still stays in the same efficiency. If you look at residential building, that energy consumption for lighting is around 4%, which is very like a small fraction. So some people actually argue that, now the lighting actually consumes very small amount of energy. Why do we need to, save more energy from lighting? But that is not really true argument. If you look at this, this is a global electricity consumption in lighting. And then in the past 10 years, you can see that the lighting energy consumption hasn't actually been decreasing. It actually stays the same way. The reason is, even if you have better technology, more efficient lighting sources, still you are building more infrastructure and then more buildings across the entire planet. So that is the reason we actually have to save more energy, and we have to find a solution here. Some people also argue that now we have a renewable energy sources everywhere, especially in California. Renewable energy is very popular. We have so many photovoltaic panels everywhere in California. So we are generating great amount of energy from renewable energy sources. But the problem is, while there is a sun during the daytime, there is a big amount of energy generated from the solar panel. But once sun sets, then we are relying on fossil fuels. So if you understand the relations between the energy consumption and carbon emission, relying on the fossil fuel energy sources is not really good for the decarbonization. So that is the reason, even with the renewable energy sources, we still have to try to find a way to reduce energy consumption. So the government policy, new technologies, and best practices, those achieved us to save a lot of energy. But wasted energy, that is actually still the problem. You can find that so many buildings and infrastructure everywhere, we can find that energy is being wasted. And then we can actually save more energy by removing those wasted energy. Wasted energy, especially in lighting, it also becomes a big problem because it actually it is affecting the nighttime sky visibility. So if you know the dark sky initiative, people actually want to see the dark sky, and then they want to be also healthy, and then they can maintain their circadian rhythm. But this more and more installation of lighting and then building, that actually doesn't actually help us to keep the dark sky. Okay, so if you look at this graph, this is the graph showing the relationship between the occupancy in building and energy consumption in building. So many people actually think that, as we have a more occupancy in building, we will have a more energy consumption. And then if we actually don't occupy the building, we will have very big energy saving. As you see in this green dashed line, right? That is the ideal relationship with energy consumption and then occupancy. But the truth is, even when we actually vacant the building, we don't occupy the building, we actually still consume a lot of energy because we keep our lighting and then we keep our AC systems just turned on, regardless of the occupancy or vacancy. So there is a very big saving opportunity we can achieve, but we are not really utilizing with the current technology. So my today's topic actually is focusing on how we can make this a reality, the relations to the ideal relations. This is the graph showing the number of Wi-Fis in a building in different days, weekdays through weekend. And then you can see the number of Wi-Fi, it fluctuates a lot depending on the time of the day and then depending on the day of the week. Okay? And then we are mostly turning on all the systems regardless of this information. So if we can find a way to turn on and off those different systems depending on the occupancy, then we can save a lot of energy. Here's one example of a parking lot at UC Davis. You can see that this entire parking lot in the campus is very bright. The street lights here are turned on 100%, even though there's no activities at night. Is this waste of energy, or is this a proper use of energy, right? If you look at this picture, it's the same parking lot, and then you can find that the same parking lot no one uses, still brightly illuminated. Same pattern you can find from the parking garage. This parking garage, the picture was taken in the middle of night. There's no incoming or outgoing car, but still, it is one of the brightest structure in the area. Why do we need to keep this on, right? That is actually same for the building, interior building spaces. We have very good renewable energy sources, which is natural light, to illuminate indoor spaces. But you can see with very nice windows full of natural light, still the lighting fixtures are turned on. Why we need to turn them on, right? We can turn them off or dim down so we can actually save energy. This is a very simple principle, but not so many buildings actually adopt this type of technology. The technology is out there, and then the practitioners understand the importance of this type of technology, but the adoption is still very slow. You can actually see from the slide, the daylight harvesting, the way we control the lighting intensity based on the natural light, the adoption rate is less than 5% in the entire United States. The daylighting design energy code, it was developed more than 10 years ago. And then we are still having less than 5% of the building to have this technology. So the fundamental lighting design strategy, that's like what explains all these problems. We have to provide the right light only where and when is needed. Okay, you can also change the light with energy, right? We can provide the right energy to where and when is needed. So understanding where and when, that is important. Adaptive lighting system, that is the dynamic system which allow you to change the intensity of the light or spectrum of the light depending on the environmental factors. The goal is to help you to maintain your health, at the same time help you to save energy in building. So there are many adaptive lighting systems available on the market in the United States now. This is the very like a simple street lighting. You can easily find from this campus too. But the difference here is this light source is LED, very high efficient LED light source. And then this part here, that is a motion sensor. So the motion detection sensor, it actually detects when pedestrian passes by this street lighting, and then it responds to that occupancy. So when there's no students on the campus, what happens? Entire campus, it reduced the lighting intensity to 20%. So it actually helps, people still be able to see it, but it helps to save energy for the entire campus. And then it only reacts to the occupant who passes by the campus. So we actually did this project 10 years ago, 2014. And then we replaced the old lighting technology to new LED technology. All the lighting technology we had was the high pressure sodium light sources, which actually consumes 150 watt per pole. Now we actually have a 40 watt LED system to replace the 150 watt. So you can actually see that huge energy saving reduction from just the changing the light sources. So, 65% was saved from the replacement. And then in addition to that, like we also save additional 18% by having this motion sensor installed. So we changed the technology, saved a big chunk of energy consumption, and then we are still saving further energy with the motion sensor technology. You can find this map of UC Davis campus. UC Davis campus is one of the largest campus in the United States because we have a agriculture major, and then we have a lot of farms, and then cow farms, and then wineries, and many different areas. And we have more than 1,500 street poles across the entire campus, and we made the entire lighting system change it to LED with a motion sensor. So here's a close-up. Very typical Cobra head LED street lighting fixture with the Philips. Philips is our very strong partner, and then they provide us a lot of technology. And you can also see this white cap here. That is a motion sensor. Motion sensor was adopted also like almost 10 years ago with this project together by the California Building Energy Code and Standard. And now it actually requires every single street lighting in California to be equipped with motion sensor. The one at the top, that is actually a photocell. So most of the current street lighting fixtures, they also respond to the amount of natural light available in the region. So that's the way we can also avoid turning on the street lighting during the daytime when it's bright outside. Because you can find that many street lightings are still turned on during the daytime. And then you can also see that it's a complete waste of energy, right? So it's how the motion sensor is detecting the occupancy and then adjusting its intensity based on that. That is what this slide is showing. So same technology was applied to many parking garages at UC Davis campus. Parking garages were very different from the parking lots. And then you can actually see that most of the parking garage lighting is turned on 24/7 because inside the parking garage is usually very dark, even during the daytime. So there is even more opportunity of energy saving by using motion sensor technology inside the parking garage. As I said, the Title 24, the Building Energy Code and Standard, it adopted the motion sensor technology in building code. So when we actually made this happen, many developers and then contractors really hated us because it actually made them to work more and then make the installation more expensive. So there's a lot of pushback by the industry, but again, this is for the society, like how we can save energy and then decarbonization, right? That is the goal here. So we were able to, overcome that obstacle and then made it in the code and standard. Title 24 also addressed the quality of light. There is an energy efficiency aspect in lighting, but there's also quality aspect in lighting. So if you look at 3000 Kelvin, that is the color temperature. How warm the color of light, compared to the cool color of the light. So If you look at this lighting here, this is pretty like a cooler side of lighting. But if you remember those incandescent lamp, those actually have a 2700 Kelvin, and then it's very yellowish, orangish warm, right? Many studies actually prove that there is a big impact of the high color temperature LED on human health and well-being. And also there's a big impact to the environment. Nocturnal animals are impacted by cool white LED fixtures. And then pollinators are impacted. Bees and moths, they are also attracted by this very bluish, cool white lighting. So that is a reason we also adopted this lower color temperature in building energy coding standard. So people actually they become more aware of the impact of use of this blue LED fixtures. This is the reason California government and CLTC, my center, we work together to address this issue. Like this nighttime pollinator, how they are affected by LED street lighting. If you can remember, like, it's in many different cities, many different countries. The first adoption of LED in streets, it was all very bright, bluish, white light. That is the characteristics of LED technology. And then it was actually the cheapest way to get LED on the street. So now people realize the negative impact by having those white LED on the street, especially at night. So we actually have a movement towards the warm white LED. And then there is actually a positive impact in the environment. So we got $500,000 funding from the California Energy Commission to address this issue. So I work with many biologists at UCLA, UC Irvine, UC Davis to understand different species, how different species actually react to different lighting spectrum and then intensity. So we can kind of understand, okay, what should be the future exterior lighting, characteristics in California. And then we can minimize the impact of lighting in our ecology, right? Wild animal and then nighttime pollinators. So now the discussion becomes much wider than before. Previously, we just focused on energy, okay, energy saving only. But now we talk about human health and well-being, and then animals and insects and many different species. So this is one kind of proposal, like we are trying to optimize the spectrum of light. So there's optical engineering and then industrial engineering. We are also adapting in this project, working with a biologist who study human and insects. And then we try to find the best solution for the society. Here's one example here. We have a exterior lighting project here in California. We developed a new technology, hybrid technology, with the photovoltaic panel mounted on top of the fixture. And then we also have the smart battery integrated in it. And then we got the funding from the government agency to replace more than 200 fixtures across state of California. Again, we targeted underserved community because they usually have a very poor nighttime lighting condition. So this is the lab testing picture to test the performance of the fixture. You can see the top is a photovoltaic panel, and then the bottom we have a LED diodes, and then there's a smart battery inside. And then we picked 7 different communities, apartments and public parks and then roadway. And these are the pictures of those existing community. We did pre-surveys before the installation of the new system. And then we learned that many community members, they got very scared to go outside at night because their area is very dark and then dangerous to walk. This is the community workshop photo for the project here. As we work with underserved community members, there have been many a misunderstanding and miscommunication about the new technology, because some people actually think that the LED can also become like a surveillance camera, like a CCTV. So they actually objected this idea. So the project team worked with a community-based organization, like a non-profit organization, so they can actually educate the community members with the technology. So there's a lot of education effort also in this project. This is one good example how people perceive nighttime lighting with their sense of safety at night. These are the 2 public parks. We did a more thorough investigation. We did lighting documentation, also with surveys of the community members. We actually studied more than 300 participants in these public parks. These public parks is in the very dangerous locations. One in California, one in LA. And then people actually don't go to those parks because there are so many homeless people and the criminals there. And many participants responded that the lighting is very dark, so they actually feel it's not safe. Okay, so there is a survey outcome here. Most of the participants actually says that it's too dark, so they actually want more light to feel safe. And then the documentation also shows that there is a problem in the lighting. And then also the high percentage of the participants, they actually says it's unsafe to walk at night. So there's many studies about the relations between public safety and then lighting system, like a lighting environment at night. And then it's very controversial because some people actually says that, a brighter nighttime lighting can make more safe environment. But also other study shows that brighter lighting environment can make people to be targeted more easily by criminals. So there are different kind of arguments about the street lighting's role in public spaces. But this project actually shows that there is clearly the need to increase the light level and then make better illumination in those areas, so people can actually stay outside at night. Okay, so now I can go to the interior spaces. We work on human health and well-being and its relation to lighting. And if you heard the circadian rhythm issue, then you can actually find the lighting topic more interesting. Because lighting is one of the major components to influence human circadian rhythm. The circadian rhythm is the biological clock in your body. So like you have a natural clock. In the morning, you want to be awake. In the afternoon and night, you want to feel sleepy, right? So you can sleep through the night. So it is very important for a human to maintain this biological clock every single day. I traveled from California to here, and then I'm actually still experiencing this jet lag here. So my circadian rhythm is not very good for now, but if you have traveled, different countries, and then you probably understand what I'm talking about. The one way to control the circadian rhythm is lighting intervention, or you can also play with the dietary pattern, like when to eat, when not to eat. Okay. So lighting is important. If your circadian rhythm is messed up, then you can experience those side effects here, like insomnia, depression, stress, poor work performance. So for students, they need to sleep well to be able to perform really good in the test and then projects. In order to understand the circadian rhythm and lighting, you need to understand that white light is a composition of different spectrum of light. Okay, there is no white light spectrum. There is this rainbow color from purple, blue, green, yellow, red, and then if you combine those different spectrum, you create white light. That's how we get all these white light systems in building. This diagram shows the different lighting spectrum from different light sources. The one way back here, that is the sunlight, incandescent light, LED, and then compact fluorescent lamp here. You can see fluorescent has a very strange spectral composition, right? It's very distorted. And then that is the reason when we see the compact fluorescent lamp, we don't actually feel very comfortable because it's very different from natural light. Okay, so having the natural light exposure to your body is very important. Circadian rhythm has been studied for decades already, and then we already know what is important to maintain circadian rhythm. If you look at this dashed line, that is the sensitivity curve for circadian rhythm, like melatonin suppression. So melatonin needs the hormone which actually makes you feel sleepy. So when you go to bed, the melatonin is secreted, right? It's generated in your body, and then the melatonin makes you feel sleepy. In the morning, there is a suppression of melatonin. So melatonin is not generated, and then your body becomes more awake. So you can actually be very active during the daytime. And if you look at this graph here, 480 nanometer or 90 nanometer, that is actually highest sensitivity with melatonin suppression. So what it means is, in easy way, if you have, this is a sky blue color region. If you have a exposure of the sky blue light at night, you are not going to be sleepy. Okay? If you have this exposure in the morning, you are going to be awake. Okay? So that is the principle here. You can see these two graphs here, one in orange and one in blue. And then you can see the blue has more 480, 90 nanometer spectrum. This orange one doesn't have any energy here. So depending on the light sources you have, you can influence your circadian rhythm. Okay? So the strategy to maintain your circadian rhythm in building is, first, to increase the exposure to sky blue light during the daytime. But you should not be exposed to sky blue during the nighttime. So this is kind of a dilemma here, right? You have one lighting system in the building, and then you have to have a completely opposite situation, right? How do we do that? Because in the office spaces or schools, workspaces, you want to have a more sky blue spectrum. At night, you go home, and then you now want to avoid sky blue spectrum. If you see your smartphone, your iPad, your computer, you can already see the transition of the color in between daytime and nighttime. There is an automatic transition already happening in your cell phone and then your iPad. Because those big tech companies, they already know this. And then they made this automatic transition to help you sleep better already, okay? But in buildings where people occupy most of the time, right? Like 90%, more than 90% of the time, we live inside the building. Most of the buildings don't have this system. At UC Davis, we have a demonstration. We built this Honda Smart Home 10 years ago. And then this building actually has many different new technologies, including photovoltaic panel, EV charging station, ground like a geothermal, radiant heating and cooling. And then one of the feature is a circadian rhythm. Okay. So this is the 2-story single family house building it at UC Davis. As I said, now you understand the principles of circadian rhythm and circadian lighting. We have 2 completely different spectrum of light. One for the daytime, one for the nighttime. And then it changes the spectrum depending on the time of the day. So this is also the nighttime image of the building. There are many like a low positioned wayfinding like a step light inside the house. The reason is as you have less exposure of light to your eyes at night, you don't actually mess up your circadian rhythm. So you have to like, let's say you wake up in the middle of night, you want to go to the kitchen, you want to go to the restroom, and then if you turn on the ambient white light, now your circadian rhythm is messed up. Then you can have a very hard time going back to sleep. This type of system, it actually helps you to avoid turning on the white light because white light actually contains more sky blue spectrum. Okay, so how to avoid that sky blue spectrum exposure in different time? That's a key. So that is one demonstration. Another demonstration we did is UC Davis dormitory space. So we used this adaptive lighting system. So if you remember me saying adaptive lighting system for the exterior lighting, the UC Davis campus, motion sensor controls, right? That is one of the examples for the adaptive lighting. If you look at this one, that is another example of adaptive lighting. And it's dynamic, changing the spectrum of the light in between daytime and nighttime based on the environmental variable. So we fabricated this fixture at CLTC, the lighting center, and then we installed them inside the dormitory space. So you can see, now you can understand which one is for the daytime and the nighttime, right? Yeah. So again, why we do this? Because we care for student health and well-being. And then we want students to be able to sleep better. That is the reason for this project. The same principle applied to the new hospital tower in Sacramento. We are building this huge hospital building in downtown Sacramento in 2030. And I have been working with architects, lighting designers, and then contractors to make this entire building equipped with circadian lighting. So same principle, we have dynamic systems in between no sky blue spectrum, and with a full sky blue spectrum to maintain the circadian rhythm of the patients and doctors and nurses. So day lighting, high color rendering, ambient lighting, those are the all important components of the circadian lighting. So design team, we spent so many hours to analyze each space in every single space in the hospital to understand who's occupying the space, and then what is the existing lighting exposure to those people. And we developed 7 different lighting scenarios of the circadian lighting scenarios, and then apply the scenarios in each of those spaces. So this is a picture showing, how we adapted the circadian lighting inside the corridor, and then it has a daytime and nighttime setting. So the full entire hospital has a circadian lighting, but still the question was about the nighttime shift workers. Like, for example, nighttime nurses, they have a completely opposite working schedule. Like they come in 8 p.m., they work throughout the night, and then they go home and sleep in the morning. So how do we address their circadian rhythm? Because if you imagine you have this as your daytime work environment, right? It's very dark, and then you don't have a much exposure of the light in your eyes, right? In your body. So your circadian rhythm can be completely messed up in this working environment. So that's why many studies shows that even the manufacturing like workers, like nighttime shift workers, nighttime nurses, they have many health problems, like physical and the mental health problems. So there was a discussion about how to help nighttime nurses to have a better lighting conditions. So we had this full-scale mock-up of a nurse station at the center, and then we tested many different adaptive lighting systems to help improve nighttime nurses' circadian rhythm. So you can also quickly see it's a very simple principle, and then it sounds really simple, but adoption of this simple transition is still very challenging. You have to really push it really, really hard to make this happen. That is a reason, even though this technology was, it was developed like 20, 30 years ago, many people understand the relationship really well now. Still, it is very hard to find the real world example, because in the end, everyone looks for the cheaper fixtures, like cheaper systems, more cost-effective systems, right? So, and then we ended up having, like poor lighting quality, environmental quality in building. So understanding this importance of the technology is the first step, and then the persistence, like pushing these ideas like to the end. That is the second, the factor you really need to make any changes. This is another, I think this is the last example of the projects, which is quite interesting. We were approached by this car manufacturer, Toyota, because this was the first time. So far we have been working with the old architecture industry, like lighting industry, and then it was first time for us to be contacted by a car manufacturer, and then we were very interested, like why they wanted to fund us. What is the question they have? Their question was very simple. Like they wanted to understand how we can influence human mood with lighting. You can be happy, sad, excited, like relaxed, right? There are many different aspects in human mood. Is there a way we can use the color of light to make people feel happier or more sad? That was the question. Why they are asking this question, right? That is interesting. The picture you see here, that is a color lab we created at the lighting center, which allows us to pick any color we want. Like we can pick, purple, blue, green, and then pink, any color as you want. That system allows us to pick the color and then create the environment, ambient lighting with a different color. So we asked them why, like why you want to do this study. And then the answer was quite surprising because they were preparing for the future. If you know this autonomous vehicle, right? Driverless vehicle, in the future, they actually say that no one inside the vehicle drives. No one needs to look outside. While the vehicle is moving, people will watch video, movie, play video game, read, do a conference call. That is the future they are imagining. They want to understand how to illuminate inside the cabin. Because even now, if you look at any typical cars, you can find many colorful LED kind of display lighting, ambient lighting inside the car. The problem is none of those companies really understand which color is good for which circumstances, right? I know that Volvo, manufacturer Volvo, they have a very cool color changing LED system throughout the entire cabin. And then you can change from blue, red, and then many different options. But they don't know what color is good for human mood or stress or different aspect. So there was a question from Toyota, like, can you at least find the relations here? Because we already have. This is the. I was on this autonomous vehicle like prototype, and then they actually showed me what they were thinking. Like as soon as I was like on the car, there was entire car. The windows were kind of blacked out. Like one button. There's no light coming from the outside, and then there was a lot of projections and then lighting. It was somewhat confusing to me if this is really car or like like a game place or a game room. But you can see like the lighting technologies were already equipped. They were talking about not even like 5 years, like 10 years later. And they still want to answer this question about human mood, how to make people more comfortable and happy inside the car. But this is their interest, right? This is their interest in car manufacturing industry. My interest is how to make people happy inside the building. If I have a hospital project, how I can use this knowledge to make people happy and healthy in the hospital, right? So we have a very different, point of view, from the different industry, but the goal was exactly the same. The project, so the project evolved from investigating human mood to investigating human stress, because we are not, the biologist. We are not, psychologist. We are, engineers and then architects. So we don't really know how human mood actually works. So we contacted another center at UC Davis Center for Mind and Brain. And then we ask them questions. Okay, can you find out, how we can analyze human mood, happiness, sadness, everything? And then they said it's too complex, it's too broad. So they asked us to pick one of those aspects. And we said, how about stress? Because people get easily stressed on the road. So we said, can we analyze the stress? And then they said, yes, we can do it. So how do we do it? We do human subject study, like a human participants. We can stress people heavily. And then we can apply different lighting color to those stressed people and then see how their stress level changes, right? It sounds like a torture, right? It's not torture, but we use this protocol, public speaking, like make people do public speaking, right? Do you enjoy doing public speaking in front of people? Not so many people enjoy it. There are people who are very good at public speaking, but not so many people really enjoy it. Most of the people, they get so stressed as soon as they are informed that they have to do public speaking. As soon as they know that, okay, 10 minutes later, you have to do public speaking here, their stress level goes up crazy, okay? So we used public speaking protocol. Oh. This is very sensitive here. Okay, so we have this EEG device, which actually monitors brainwave pattern. And then we put it on the head of the participant. And we make them do public speaking in front of live judges. So we have two people wearing white gown, white mask, and then they show no facial impression. They don't smile, they don't shake their heads or nod their head. They just stare at you. That gives a lot of pressure. This is called the trial social stress test. Very well validated study protocol in psychology. So we use this protocol to make people stressed. And then we monitored their brainwave pattern throughout the entire study period. We also collected a saliva sample because if you collect saliva sample, you can analyze cortisol hormone level, which is also known as the stress hormone. So we look at those two different, physiological responses. So you can see how the EEG device it was put on the scalp of participant. We tested more than 100 participants in this study. And then we put the stressed person inside the color lab with a different lighting color. In this study, we only tested 5 different colors: red, green, blue, amber, and white light. Why didn't we test more? There are so many different colors, maybe purple, yellow, green, right? Light green, dark green, so many different colors. But there is also limited budget in every single project, right? You have a budget, you have a project time. So this is the way you actually develop the research methodology, with the real resources and times and efforts and everything. So we only selected 5 different colors by hoping that there must be some relations here. Like we actually told the Toyota people saying that, we can do this study. There's a very strong research protocol here, but we might not find any relations. So at the end of the study, you can go with nothing in your hand. They understood because it's very hard to imagine that there is any relation, like strong relations in between those two. So like green, blue, and amber, and then the white color. So as I said, we monitor the frontal alpha activity. I'm not, brain scientist here, so they actually provided this methodology. And then what I learned from them is when you have a very asymmetrical brain activity, left and right, that is the indication of a high stress level. Okay, so that's how we understood the stress level. If you look at this graph that is out of the EEG device, you can see the x-axis actually is the time period in the study. Rest, task prep is the public speaking preparation, and then actual public speaking, and then recovery in the color lab. And the y-axis is the level of stress. You can see as we go high, that is a high level of stress. Okay. So as you see here, task prep, as soon as they hear, okay, there will be public speaking, their stress level is peaking. Okay. And then it peaks in the middle of the public speaking, because most people, they actually feel very comfortable after they go over halfway through their task. They feel that, okay, now I'm doing good. And then now there's a light at the end of the tunnel, right? So they be more optimistic. And when you go into the recovery, there is a natural decrease in stress level. So there's a natural mitigation process in the recovery phase. But the question is, which color can accelerate this stress recovery, right? That is the question, because you can understand that this white light is kind of a baseline here. That is the control group. And then we want to understand if there's any other color which performs better than white light. Okay? And what you see here, there's a big difference with the amber light. Okay? This is a normalized data. What we did was, if you look back here, there are different group of people in each color, and then they have a different levels of a peak stress level here. There's a peak stress level, they are all different. So when they studied their exposure in different color, their stress level is also different. So what we did is we normalized the stress level to the point of the color exposure, and then we saw the difference. And then we saw that still amber color actually performs way much more better than white and all the other color. If you look at blue, green, and red, they actually slow down your stress recovery compared to white. So what it means is when someone is stressed, if you try to help them with a blue color, red color, it's not helping. It's better to just turn on the typical white light to them. But this amber lighting, it actually has 70% better performance recovery rate compared to white. So we have actually patent pending here, and then we license this to a company in South Korea to make stress mitigating lighting. And we work with UC Davis Hospital, UC Irvine Hospital to have this lighting in the spaces where the high stress is associated with. So imaging room, like a scanning room, and then X-ray, MR, and then pre-operation room, infusion spaces, like where you actually have to put your like a needle in your arm, and then pediatric spaces. There's so much stress associated with those spaces because people know that something like their pain is coming. So we talk to the doctors in those areas and the disciplines, and then they actually shows a lot of interest adopting this technology in those spaces. So we are adopting those that technology in those spaces in hospital. And then this is the kind of stress mitigating lamp we are developing with a company in South Korea. So that's what how we also move the research projects from academia to the marketplace. So that is actually kind of a technology transfer out of this like a fundamental research project. All right, so I wanted to show many different types of projects we are doing. You can actually see that we have many focuses on energy saving, those very engineering oriented projects like motion sensor, LED efficiency, system efficiency. Those projects doesn't really involve much of the human factor, but we also have projects really focusing on, human health like circadian rhythm and then human stress at the lighting center. And because I wanted to show that, it doesn't really matter which discipline you are in now. There is so much potential, like opportunity available by working with, different researchers in different discipline. The type of research is you saw here, I'm always working with the new partners, engineering professors and architecture professors, urban planning professors, psychology professors, the brain, center, researchers. These collaborations are very common nowadays because everyone now is looking for the new research topic and new research area. Okay, so that's the the perspective I want you to have in your career, and then you should be really open to any new collaboration opportunity and then the discussion opportunity with different professionals. Okay, don't just stuck in the same discipline. Make the more network and connection with other researchers in the future and the professionals in the future. Okay, that's it for my presentation today. I appreciate your attention today. And any questions? Oh, yeah.
Thank you so much. Hello, hello. Thank you so much, Jay. So now we're gonna open for questions. So, vamos a abrir el espacio de preguntas ya. Vamos a partir por ahí, ¿cierto? Y te voy a pasar el micrófono para que la puedas hacer como tú quieras. Si necesitas, la puedes hacer en inglés, si no, yo te traduzco.
Yeah. Yeah. And I'm Agustin Bravo from Electrical Engineer.
Oh,
from
yeah.
Fisker. Yeah. Well, if I may ask, what is your personal advice to us, to Chile as a whole, to further improve and enhance in our and apply in our all of the lighting technologies and energy savings, all of that in a sustainable way? What should be our focus area, our main focus?
Your home, you said, right?
Hmm?
For your home or lighting for your home or?
In whatever case.
Okay, so the lighting technology, if you talk about energy perspective, energy aspect, then LED transition is the first thing you do, right? So you have to change from fluorescent incandescent to LED, right? That's the first thing you need to do. If you consider your health, circadian rhythm, sleep pattern, sleep quality, then you have to think about this blue spectrum, right? Either having blue spectrum or not. So in my house, for example, I have a very amber, like a low color temperature LED lighting. So because when I actually go to my office, I have a LED with a high amount, like a high energy in the blue spectrum, right? Very cold color white. When I go home, I don't need that type of lighting anymore. All I need is to, the fixture which actually can relax me and then make me feel sleepy. So depending on the location and application, you need to have a different system. Okay.
Thanks.
Yeah. Thank you.
Sí, estaba intentando mezclar.
¿Cuál sería como, dependiendo de las disciplinas? ¿Quieres que se la traduzca? No. ¿Tenemos allá otra pregunta?
Hello. Hi, my name is Dr. Square, and I'm a student of civil engineering from the same university we're making this talk. So my question is, in regards to the motion sensors and all those illumination systems, have they considered the security measures in regards to whenever there's not movement in that space? Since there are some places where there's a high level of criminality, if I'm aware. So in those places, there might be some like places where they could make an ambush for someone if the motion sensors don't detect them.
Yes, that's really good question. The safety and security is very important. So that's why, for example, like a police department, firefighters, they strongly object any control of lighting at night because they want everywhere bright, right? So they can see these potential criminals or criminals. So this motion sensor triggered lighting, it actually doesn't suggest to turn off the light. It actually suggests to lower light. Okay, we have a limit in the how far you can make the lighting dark. So as long as you don't turn off the light, you still have a very good visibility. The problem you might notice already, it was interesting for me to see the difference between the street lighting inside downtown Concepcion compared to the freeway and then the infrastructure side. Because freeway, it has LED fixtures everywhere. Here, I have a hard time like finding LED fixtures. So the problem is LED becomes more and more efficient. What it means is if you use same amount of energy, you can make this source much brighter. Okay, so what's happening now is everywhere we spend our time in building, outside building, everywhere it becomes actually more brighter and brighter. Because in the old days, there was a concern about consuming too much energy in lighting. But now, even with like a 10-watt LED bulb, you can generate a lot of photon energy, right? And then this LED technology improvement, it didn't actually stop here. It becomes more and more efficient. So you can actually understand everywhere is becoming more bright. Okay, so when we have this over illumination issue, like in outdoor spaces, we actually have to find the way to reduce the amount of energy. So security, safety, we don't recommend this motion sensor for the roadway, like where the car is like driving so fast, because we are concerned about the security and safety of the cars and passengers. But if you look at many other places like this campus, public parks, and then parking lots, parking garage. There's so many fixtures in those areas, and then you have still a lot of opportunity to save energy without really concerning about the security issue.
Thank you. Otra pregunta por acá.
Hi, I'm Lukian Sansana. I'm a third-year architect student. And at some point of your presentation, you mentioned about switching to motion sensor and warm lighting being a problem to some of the companies. But I'm interested in hearing about how can that be implied in Chile? Like, is it the cost too much to switch into these new motion sensor lights to implement them in our country, since we are not really as advanced like the United States or other countries?
So you can go one by one. The first step is to move to LED, right? LED technology. If you compare the cost of LED systems and also the cost of motion sensor, compared to 10 years ago to now, the cost actually has dropped significantly because now every company is making LED. If you see California, fluorescent and then incandescent lamp, actually those are banned for sale. So no one can buy even those sources anymore. So everyone is manufacturing LED, right? So that concern, I still believe, I still agree that there is a concern about the cost, but compared to 10 years ago, 20 years ago, the cost effectiveness improved a lot. So there is a much better opportunity for the cities and then campuses to adopt LED with a motion sensor. The payback time is going to be the issue. So if you think about this potential energy saving with the motion sensor operation, right? So whenever you lower light, right, with no occupancy, there is energy saving. The question is how expensive the electricity cost in Chile. That is the question. In California, the electricity cost actually is going higher every single year. So even if you save like 10%, that becomes a big money saving in your pocket. So the question here is it really that expensive? The energy cost in Chile is expensive, or you see the potential increase in the electricity cost in Chile in 5 years and 10 years? If you see that, this is the right time for the government and then the university to make that investment. Because UC Davis, that 10 years ago we did that conversion, the amount of electricity bill like they saved is huge. When we first discussed that idea, no one expected that we are going to have this much of energy saving and then the utility bill saving, right? So you need to actually look further, and then you need to better understand your societal system here, about the electricity, utility company, how utility company provide electricity. Is it fair for the users and then the taxpayers or not? There are so many questions actually you have to ask. But my recommendation is still for you to understand that the technology is available and then also being adopted in different countries. So you also can make a proposal, when you graduate, when you are in the right position, and then you can make a proposal. Okay, can we discuss this idea? That's what I also recommend, Professor Andrea Martinez to start discussing building energy code and standards in Chile, because that is really the first step. You can improve, building energy system and then the quality of life in building. Okay. Thank you.
Okay, thank you.
You give me a big responsibility. ¿Sí? ¿Sí?
Jay, thank you very much for your interesting talk.
Yeah, thank you.
Yeah, I enjoyed it very much. Yes, I agree with you that the first step would be to transition to LED, and you, at the end, just make the point that we really need policy and regulation
Yes.
before we do that, because we started, I think, the wrong way here in Chile.
He was asking question.
So, so yeah, I think we need to really work on policy, as you just said, and regulation. So how to start with that? I think everyone here is invited to push, because it's the society that pushes for new regulation. What I'm interested, this is just a comment, but what I'm interested is about the amber light. The amber light doesn't seem, because you showed this spectrum,
Oh, yes.
doesn't seem to have this peak at the blue end of the spectrum.
Yes.
But the other LED, it does. It's a very different technology.
Yeah, this is, every single LED manufacturer, you can assume that they have their own recipe, how to create white light. So depending on the type of company you are working with or you're purchasing from, they have their own way to create white LED. So if you, this one, right? Yeah. So that is the reason. Like also, it's very important for you to understand the specification, like performance specification of the product. It can be lighting or HVAC, any other systems, because you have to understand the different specification to see which one actually is more beneficial for your purpose, right? So you can buy the same LED from a very like a poor manufacturer, like very well-known manufacturer, and then there is a clearly difference in this spectral composition. Okay, so when you consider maybe like different type of LED technology for your study, then the first thing you will do next time, like you will see, okay, if this LED has this blue spectrum or not. Now you know that, right? This is important. And then every single specification they provide, they're required to provide this information. Yeah. So once you know this, then the next question is like, how to do it, like what to do with those technology. Yeah.
Is it much different technology? Is it much more expensive to get the amber?
Oh, yes. So amber is more expensive compared to this very white blue LED, because in order for you to have more distributed spectrum, like a natural light, you have to apply more phosphor material and layers. So there is a more cost on top of this. We actually called blue pump LED. So all the white LED is start with the blue LED, and then we apply layer of the yellow. When the blue light passes through the yellow phosphor, it turns white. So you have to now apply more material, which actually increase the more cost. And then it also make the LED system less efficient in energy consumption, because now less number of photons can penetrate through this thicker phosphor, right? So many people in the past 10, 20 years, a lot of people, including myself, we only focused on energy efficiency. So we only looked at, okay, this LED, it has 100 lumens per watt or 110 lumens per watt. That was the biggest question. And now we actually understand these relations in between energy efficiency and then quality. Okay, so now you can actually see the more amber lighting, that is less efficient, more expensive, but that there's a good benefit, right? So now the question is like, again, you have to push it like through this idea because there's a more like a cost associated. But again, this is the same as all the LED fixtures, like LED, like cost is dropping every year. So now, what is the cost of this, A-shaped LED bulb? This is, it used to be like more than $10 per bulb, like 10 years ago. Now I think it's like $2, $3 maybe per bulb. Yeah, so you can see the big changes, like big shift in the cost of the technology too.
Thank you very much.
Yeah, thank you.
So we're gonna no. So we are gonna take just one final question because the
okay.
students have another like block for classes. Okay, so this is gonna be the last question, Jay.
Oh, okay.
And then we're gonna.
Hi, my name is Orlando. I'm a civil engineer. I had a question about the Sacramento hospital
Yes.
that was going to be built in 2030.
Yes.
I was had a question: has there been any studies on like worker efficiency and well-being after, especially in the night shifts? Because I thought that since they will have a better circadian rhythm and they will get sleepier at night, then maybe they would have to take other measures to stay awake during their night shifts.
Yeah.
So maybe it would be kind of counterintuitive for
Yeah.
them to be in that setting.
Yeah, thank you for the question. I should admit that the nurse station lighting we proposed is not really perfect solution for the nighttime nurses because I learned myself that the nighttime nurse, the regular nurse, their schedules are very complex. And then I also learned that nighttime nurses, they actually don't go to bed after work. After work, they spend time with their family. And then they go outside and then they do more activities. So their circadian rhythm cannot be opposite permanently, right? And then there is also a group of people like who make a fast, like a shift in work schedule. So some nurses, they just work nighttime for 2 days and then they go to like regular work schedule. So I had many ideas about, okay, what if I can have this sensor, like a monitor on the human body? It actually monitors the activity for entire day. And automatically, it changes the perfect lighting system, the condition for you, right? So there's an idea, there's a technology available, but we are not really ready to push that idea really further. So in this case, we proposed all the dynamic lighting options. So pendant, downlight, and then table lamp, under cabinet lighting, everything should be a dynamic LED system. And then we also asked electrical engineer to have a communication, system available there, like additional wiring, because we believe that 5 years later, it's going to be ready. This idea of the sensor monitoring and then realizing which person is like which person, like in different location, that is going to be ready in 5 years. I think 5 years is sufficient period to make it happen. So this building, when we designed like maybe 3 years ago, it's going to be completed in 2030, right? So there's maybe 8 years of a term here. But when you design a building, when the system is not considered or included in your design, it cannot never build. So what my proposal was to have all this future technology capacity available now. So make additional wiring, like additional capacity in electricity. And then when we have that technology available, we can easily install the additional device to the nurse station, right? So this is also one way you can develop a project for the future, because many people give up a lot of creative ideas because of the lack of availability of the technology, and then people's willingness, passion. So we actually kind of compromised in between. Like we make the systems ready for the future, and then the hospital actually accepted that idea. Okay, so don't doubt that this technology development will take forever, or it's gonna be too slow for you to achieve something new. The technology development is pretty fast, and then it's going actually faster and faster, as you see with all this AI, right, development. So just look at the future and then see what you can propose, best at your moment now. Okay. Yeah.
Thank you, Jay. Thank you for all the questions. So we are gonna give you a final applause, and thank you for being here, Jay. And gracias a todos por venir.
Thank you. Thank you.
Ya. Esperamos que haya sido muy informativo, muy interesante para todos y bueno, lo que dijo Jay, ¿cierto? Empujar y empujar para la interdisciplina. Así es que acá muy feliz también de ver estudiantes de ingeniería, de arquitectura y de otras carreras, también todos reunidos. ¿Ya? Así que tengan todos una buena tarde.
Thank you. Yeah, it was fun.